Good day, great souls, and welcome back to the Anti-Science Theory. So today I want us to just consolidate chemical equilibrium with with the help of a question. You know, I'm gonna do a couple of question papers as time progresses, but I just want us to look at this one for now. So this was from the from the November exam of 2022. So it says here, carbon reacts with sulfur according to the following balanced equation. So that's carbon plus sulfur to give us carbon sulfide. So notice how this tells us that our reaction is exothermic. Tells us that our reaction is exothermic. Right. Okay. So it's a reaction between carbon and sulfur to give us carbon sulfide, or you can also, most commonly known as carbon disulfide. Oh my gosh, carbon disulfide. Okay. So we already have an exothermic, not exothermic, but endothermic. So sorry. I just saw that delta H is greater than zero. So it is endothermic. Pretty sure you guys were like, what do you mean that is exothermic? My gosh, what are you saying? Endothermic. Right. The system reaches equilibrium at some temperature T in a sealed 2 cubic decimeter container. The Kc value that we've been given is 9.4. Remember what it means when Kc is greater than 1, then we have more products and reactants at equilibrium. They then state Le Chatelier's principle. Remember, that is when the disturbance in an ice in a when um equilibrium when equilibrium in a closed system is disturbed, the system will reestablish equilibrium by favoring the reaction that will counteract the disturbance. Right? That's your 2 marks there. Then they say at equilibrium, we have 1 mole of carbon disulfide, like I said, is present in the container. Calculate the concentration of sulfur present at equilibrium. Notice something, guys. We have a reaction of carbon plus 2 sulfurs to give us carbon disulfide. So notice something. I have solid, gas, gas. Remember, Kc only works for gases and aqueous substances. If it's a solid or a liquid, the concentration is 1. So they want the concentration of S2 present at equilibrium for 4 marks. So we set up the equilibrium equation. What is this? Question 6.2. So we set up the equation. So Kc equals to the concentration of the product. You don't have to write this all the time in the exam, guys. The concentration of the product of the concentration, I do recommend that you do, but you don't have to. Of the concentration of the reactants, right? So we have been given that the Kc value is 9.4. So say then Kc value is 9.4. And as a result, this is then going to be equal to the concentration of the product. What is our product? Carbon disulfide. Concentration of CS2. Do we have any exponent? No. Why? Because we have no stoichiometric coefficient. And I divide this thing by, okay, before I substitute anything, let me just still keep this as Kc for the sake of consistency. Then I'm going to have at the denominator my products, the reactants, sorry, there will be carbon multiplied by sulfur. But remember, sulfur has a stoichiometric coefficient of 2. Therefore, that 2 will be an exponent. Now, if I further simplify, or now if I calculate, the Kc is 9.4. They want the concentration of sulfur. They want this guy here. Okay. They want the concentration of sulfur. We do have the concentration of carbon disulfide, and they said it's 1 mole. Oh no, they gave us the moles. They didn't give us the concentration. But with Kc, we need concentration. So we first need to calculate that. So we're going to say the concentration of carbon disulfide at equilibrium will be equal to the number of moles, which is 1, divided by the volume given, which was 2. So that will then be 1 over 2, which gives us 0.5 moles per cubic decimeter. So this will then be 0.5. Okay, and then I divide both sides. Remember, this carbon is a solid. So what is the concentration? 1. Okay, and then I want S squared. So now I'm going to use some mathematical gymnastics here. So 0.5 will then be equal to 9.4 S squared. Divide both sides by 9.4. Divide both sides by 9.4. Zip zap. So S squared will then be equal to 0.5 divided by 9.4. I get a value of 0.0532. However, this is S squared. We just want sulfur, not sulfur squared. So this will then be sulfur with the square root of both sides, which is then going to give me square root of the answer is 0.231 moles per cubic decimeter. So those are the moles of sulfur at equilibrium. Sorry, the concentration of sulfur at equilibrium. That's very important to note. That's the concentration at equilibrium. Right. I really hope that was clear. No one is confused. Okay. So now we go to question 6.3. So at 6.3 it says, the volume of the container is now doubled at temperature T. So remember that the container initially had a volume of 2 cubic decimeters. Now at a new temperature T, it's now doubled, so that's times 2. Therefore, the new volume is now going to be 4 cubic decimeters. Okay. Now they say, how will the amount of sulfur change as this new equilibrium is reached? Oh no, sorry, I didn't read it after. I didn't read the whole thing. So they're saying to us that the volume is now doubled, therefore the new volume is the one that we've just written there. Let me just take that and put it on the side. Let's put it here. Okay. After a while, a new equilibrium is reached. Now we have reached a new equilibrium. Now they say, how will the amount of sulfur change when the new equilibrium is reached? Choose from increase, decrease, or remain the same. Now let's think about it. Will this thing increase, decrease, or remain the same? So let's see. Okay, let's think about it logically. Now, I'm trying to find out, now that I have new equilibrium, will this guy's concentration or the amount of sulfur increase, decrease, or remain the same? Notice how this guy's amount is affected by the volume. Since I have new volume, I need to also have a different amount of sulfur, basically. Okay, so let's see what happens. How many moles of sulfur did I have when the concentration was 0.231? So C equals to N over V. Therefore, the moles will then be 0.231 times the volume of 2. And then I initially had 2 times 0.231, and I had the number of moles as 0.462 moles. Okay, so those are the moles that we had with the first volume. So these are the moles that we had with the first volume. Now, what would happen to the moles when we have a different volume, right? So, if now, let's think about it. If now I have a volume of 4 cubic decimeters. So let's see what happens with this new volume. So now I'm going to say number of moles equals to the concentration times the volume, which will then mean the concentration is 0.231, that one that we had before, times the volume of 4. This will then give me 4 times 0.231. And as a result, I end up with the number of moles of 0.924, which is bigger than this. So notice how my number of moles, or the amount of sulfur has increased. Therefore, the answer here will be increases. And that's your answer. You could have a different way of explaining it. I mean, there's probably more than one way to do that. Okay, so 6.3 then 6.4 then says, explain the answer according to Le Chatelet's principle. Oh, they love this question. So I'm going to give you a way of how to answer these things. The first thing that you need to do, guys, before you answer questions on Le Chatelet's principle, this is where you need to tell us about what happens with an increase in the which reaction will be favored and stuff like that, basically. So that's typically how you answer questions on the Chatelet's principle. You need to tell us what happens, which reaction is favored, and such things. So the first thing that you need to do is you must be able to first identify the type of disturbance. You must first identify the disturbance that you have. So let us see. Let's see. Okay, so carbon reacts with sulfur. Okay, now they're saying to us, the volume is now doubled at temperature T. After a while, a new equilibrium is established. Then they ask, how will the amount of S2 change as the new equilibrium is established? Choose from increase, decrease, or remain the same. Now, let's think about it. This question basically wants you to think about it logically. Like I said, instead of using this explanation of calculations, we can think about it this way. Before I answer this question, I want to give you a different logic to this thing. Now, remember, we have an endothermic reaction, and they're asking us about what happens when the volume has increased. What do you know about an increase in volume and pressure? Remember, when you increasing the volume, the pressure must decrease. Aha! So let's see. Oh my gosh, let's see. So I have carbon plus 2s2 to give me carbon s2. What? No, that's not right. That's 2s, not 2s2, sorry. So that's 2s. So I have gas, gas, solid. So now check what happens. Now we've already established that since this guy increased, the pressure must decrease. Remember, we've covered this one. What happens when I have a decrease in pressure? Decrease in pressure favors the side with the highest moles. How do we check? We check the stoichiometric coefficient. But now remember that this is a solid. So the stoichiometric coefficient, when you're checking the number of moles, we take it as 0. So this becomes 0 plus 2 against 1. So this is 2 moles and this is 1 mole. So a decrease in the pressure will go to the side with the highest moles. Therefore, in this case, the reverse reaction was favored. And when the reverse reaction is favored, what happens? The yield of this thing decreases, this increases, and that increases. That is also another reason why we said the amount of sulfur was gonna increase. I don't know if you guys are seeing the vision. The only reason I said this was going to increase is now you're seeing a different explanation to it. This will also have to increase. Okay, now let's explain all of this in words by making reference to Le Chatelet's principle. I'm going to put it on the side. I'm going to put it on the side. Okay. Now, please ensure that when you're answering such questions, avoid writing in paragraphs. Please, please, please. So point number 1, I tell them what happens. An increase in the pressure, an increase in the volume, an increase in the volume decreases the pressure. That's my first point. My second point, comma, an increase in the volume decreases the pressure, right? That's what we've established here. Now we need to tell them which reaction will be favored and why. So an increase in the volume decreases the pressure, right? Thus, the side, right? You can say the side with the highest moles, right? So the side, or the reaction rather, let's say Okay, let's just say the side, basically. So when increasing the volume decreases the pressure, thus the side with a greater or higher, right? The side with a greater amount in moles. Remember now I'm taking what I've done here and I'm putting it into words. An increase in the volume decreases the pressure. Done. Thus, the side with the greater amount in moles. Okay, we've already established that the pressure will decrease. Thus, the side with the greater amount in moles will be favored. Will be favored. An increase in the volume decreases the pressure. Done. Thus, the side with the greater amount in moles will be favored. That's that part over there. And as a result, there's your conclusion. As a result, the reverse reaction is favored. And you're done. Thus, as a result, the reverse reaction is favored. And that is that, ladies and gentlemen. That is that. Simple and simple as that. Notice how I did not write paragraphs. Please do not write a paragraph. It's very important to not write a paragraph. We do not want to see paragraphs in the marking center, guys. I mean, I don't think they'll penalize you, but it's highly recommended that you write it in point form and not in paragraph form. I don't want to lie and say they might penalize you. They probably might. They probably might not. But please avoid writing paragraphs. Keep it in point form. Okay. In most cases, if you need to explain things according to Le Chatelet's principle, please first have this illustration on your own. Understand what you do here. Take this thing and put it into words, and that's that. You are done. Okay, right. And if you wanted to add more and be more like, I don't know, if you wanted to add some information, be more pedantic when it comes to this, you could have just said, as a result, the reverse reaction is favored, therefore the amount of sulfur increases. That would have been just an addition to that. But I mean, you would have been redundant in a way because you've already told them that it increases in 6.3, you know? Anyway, I hope that was very clear. 6.5 then says, if the concentration of CS2 changes by X moles, write down an expression for the equilibrium constant in terms of X. Ah, nice question. Show all your workings, no simplification or solving for X is required. So they're basically telling you that you don't have to solve for X. We just want to see Kc in terms of X. Now remember they're talking about Kc. Therefore, you need to call upon the ice table. So that's initial. Remember, I like to put this thing in moles. And then you have the change. You can once again put it in concentration. Moles per cubic decimeter. That's not a problem. And then I have the moles change. And then I have the equilibrium. Equilibrium moles. Right. So this is what I have. Mm. Okay. So now I then put in my things in the reactants, which I have the carbon. So I have the carbon, I have the sulfur, and I have the CS2. Now remember the stoichiometric coefficients, guys. For carbon it was 1, for sulfur it's 2, and for CS2 it's 1. Okay, so let's see what happens here. I don't know why I'm literally so focused on making these lines straight. But no, man. Yeah, things must be neat at times. Okay, so let's take our information and plug it in. So let's see. So for the so what do they say to me? If the concentration of C2 changes by x moles per cubic decimeter. Write down an expression for the equilibrium constant in terms of x. So they are saying, notice how they made it in big bold letters. The concentration of the product changes. So this must go into the change part. So it changes by x moles. It changes by x moles per cubic decimeter. So since I have moles, I need to turn that into cubic decimeters. So if the concentration equals to N over, remember they gave me this X in moles per cubic decimeters. That means they gave it as a concentration. I want to turn it into moles so I can substitute it into my table. So I'm going to say moles equals to X moles per cubic decimeters times the volume of 4. Right? Remember that's the new volume. Therefore, the number of moles will then be 4X. Okay. So this will then be 4x. Now, initially, you would then remember, okay, now from here, to get the values of the carbon and the sulfur, you would then need to do the stoichiometric ratio. Remember, it's only at the change part. It's only at this part where you can use the stoichiometric ratios. So I'm going to say the ratio of sulfur is to CS2 is 2 is to 1. Therefore, this will then mean I do not have this, but I do have this as 4x. This is then going to cross multiply. The number of moles of sulfur is then going to be 8x. So this is then going to be 8x. Remember, you can only use the stoichiometric ratios when you are at the change part. So notice how the ratio of carbon and CS2 is the same. Therefore, the number of moles must be the same. Therefore, this is also 4x. Okay, so now what else do we have here? Let's see. Okay, we don't really have much. They're just saying you must just write Kc in terms of x. That's all that they're asking from us right now. So we just need to have Kc in terms of x. Now let's see how we can do this. Now I want you to notice something. Notice how we have carbon here, which is a solid. In most cases, your teachers might tell you not to include carbon on your ICE table because it's your, what is it? It is a product, right? Not a product, sorry, it is in solid form. I'm so sorry for losing my train of focus there. They are going to tell you to not include the carbon because it is in solid form, basically. Right. So, what will happen now is in order for me to determine what I will have at equilibrium, I want you guys to think about it. What were the moles, or what was the amount of sulfur that we had, the moles of sulfur that we had? We calculated those ones as, there we have it here, ladies and gentlemen, 0.462. That was with the concentration of 0.231. So this will then mean that the moles that I have here are, what is it? 0.462. Okay. So that is 0.462. Now I need to get the concentration at equilibrium. Equilibrium is basically us saying it's at excess. Now remember our equation. Remember the equation. We are saying the number of moles original must be equal to the number of moles that react, or we can say the number of moles change, minus the, plus the number of moles at equilibrium. So the original was 0.462, right? And no, we actually need to use the moles when we have a volume of 4, not the volume of 2. Remember, now we are using a new volume, so I can't use the 0.462. I don't know if you guys would agree with me on that one. Remember now, I'm talking about the volume when it's at 4, not at 2. And those number of moles that I got here for sulfur were the ones for the moles when the volume was 2. And like I even said here, is when we were using the first volume. Now for the new volume, the number of moles must change. So you have number of moles equals to the concentration times the volume. The concentration here would have to be the 0.231 that we calculated there times the volume of 4, and we get the number of moles as, let's see, 0.231 times 4. That gives me a value of 0.924 moles. So that's what I should put there. 0.924 2, 4. And remember, this is going to be 0 because there's initially nothing of it, right? And they didn't tell us anything about it. Here you can just not write anything here. Remember, like I said, your teachers will tell you not to include it because this is a solid. Kc doesn't work with solids. In fact, the concentration is just 1. We don't really look at it. Okay, then that means the change here at equilibrium for this one will be 4x, and then this one will then be supposed to be 0.924 here. So 0.924, and then the change was 8x, and then the number of moles at equilibrium is what we want. So you want the moles at equilibrium. So the moles at equilibrium will be the difference between these two. Therefore, at equilibrium, we are going to have 0.924 minus 8x. So 0.924 minus 8x. And there we have it. Now we can write our equilibrium constant nicely. But remember, we can't have these things as moles. For the Kc, we need to turn them into concentration. So I'm going to say for the concentration of sulfur, the concentration of sulfur at equilibrium will be the number of moles, which is 0.924 minus 8x divided by the volume of 4. So this will then be 0. So I'm going to break this up. This is going to be 0.924 over 4 minus 8x over 4. This gives me 0.924 divided by 4. That gives me a value of 0.231 minus 2x. And then for the concentration of, what is this? The CS2, this is then going to be the moles, which is 4x divided by the concentration of 4. Was it 4x? Yes, divided by the concentration, sorry, the volume of 4. I should get this as just x. This should be just x at equilibrium. Okay. Is that fine? That should be fine. Let's see. Okay. Just checking my calculations here to see if I made any mistakes. Hopefully I didn't. Concentrate on number of moles over the volume, which is 4x over. Okay, so let's see. Now for the Kc constant, Kc will be equal to the product, in this case, which is CS2. Does it have any exponent? No. Then I divide that by sulfur, which is an exponent of 2. And then this CS2 was what? Was initially x. Then I need to divide that by sulfur, which is what? How much is sulfur? 0.231 minus 8x. So this must then be x over 0.231 minus x. What am I doing? Never mind. This is how we will leave it, basically. This is how it stays. We can't simplify further here. So we're just going to leave it here. So that is our Kc. Okay, but now I'm thinking about this information. Because now if you think about it, if we look at this information here, they say to us that we had initially 1 mole. At equilibrium, we had 1 mole of carbon disulfide. And that's the number of moles that we had here. It was not supposed to be 0. You see the error that we had made there, right? Remember, think about it. If at equilibrium, we had 1 mole, that was for the initial equilibrium, right? So this value here cannot be 0. That value needs to be 1. Sorry. And then from there, I'm seeing a lot of errors that I've made here. Just gonna have to redo this whole thing because I'm seeing a lot of errors. A lot of what I've done here is made a lot of mistakes here because I literally did not consider the initial information that I was given. So a lot of mistakes have been made. So I'm just gonna rectify my errors. I'm pretty sure some of you had actually seen these things. I'm like, no, but how is this possible and how is that possible? Unfortunately, you couldn't really voice out, but yeah, I'm seeing the mistakes that I've made here. Just fix a couple of things here. Okay, let's see. Okay, now let's fix these things. Okay, so let's fix our errors, guys. Let's fix it. Let's see. Let's go back to reading the information clearly. Okay, I'm gonna have to raise a lot of these highlighters and everything because I need to now see things clearly. I can't be making unnecessary mistakes. Let's see. At equilibrium, we were told, okay, we did get a Kc value at some temperature T, right? Remember, this temperature T is for the entire question, the Kc value. So I've already established that my Kc value should be 9.4. Okay, and I'm going step by step. Okay. Then they said equilibrium, I initially have 1 mole of carbon disulfide present. That is the initial equilibrium, right? I have 1 mole of carbon disulfide that is present. And then they say calculate the concentration of sulfur. Okay, we've done that. Now, there was some concentration of sulfur present at the initial equilibrium. Remember, now there was a new equilibrium established. So let's just try and see what happens there. Did I not set that thing up? Okay, then I had these concentrations. Let's do that. So I'm gonna set up a table where I'm gonna have the old equilibrium and then the new equilibrium. Just gonna add it onto this table. Okay, okay, let's see. Now, gonna have to erase a couple of things here. Okay, there we go. Now, let's understand something. I had an old equilibrium. And obviously with an old equilibrium, I'm going to have those previous number of moles and the concentration and everything in between. So now, I need to see what happens when I have a new equilibrium, right? That's when there was a change in the concentration of the product CS2. So I had an old equilibrium, still in moles. Okay, so I had the old equilibrium here. And at the old equilibrium, what happened? I had 1 mole of carbon disulfide in the container at the old equilibrium. So there was 1 mole of carbon disulfide. So I'm going to have here, let me erase this last row because we're not going to include, okay, but it's fine. I'm just going to put dashed lines there. So I'm going to have 1 mole of carbon disulfide. So for this thing here, let's do this. So I'm going to have, in this case, carbon, sulfur, CS2. Remember here we had 2, we had 1, and we had 1. So the old equilibrium for carbon disulfide, I had 1 mole. Then for sulfur, what was the moles that I had? That's at the old equilibrium, right? Old equilibrium. Guys, please pay attention. Old equilibrium. And with the old equilibrium, that was just before we had the volume doubled. So that's when we take this value of 0.231 when the volume was still 2, the concentration was 0.231, but what were the number of moles? The number of moles was 0.462. This is at the old equilibrium. Why? Because that was the equilibrium before we had a new volume. Okay, so the concentration, the number of moles there was 0.462. So I'm going to put dash here because we're not going to consider that. Dash, 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 dash. And then now what happens? Now we are then going to say, I need to now introduce a new equilibrium, right? However, with that being done, remember that I had a change, right? I had a change in the concentration of CS2. That was my change. I had a change in the concentration of CS2. So this will then be my change. Then this will be my new equilibrium. So the old equilibrium, you take the old equilibrium results and they become the initial results. So I'm just gonna put that there so that you don't get confused as to, but we usually have initial. So the old equilibrium, please listen to what I'm saying. The old equilibrium results we're gonna use as the new initial results. So this is the initial results for a new equilibrium. Basically, that's what I'm saying. Okay, so at the old equilibrium, I had this information. Then they say it changed. CS2 changed by X concentration. So to get that concentration, I need to say C equals to N over V. And this is then going to mean, what were the number of moles going on here? Now think about it. So it changed by X concentration. So this is X. What were the number of moles? We don't know. Therefore, the number of moles here where the volume is now 4, this is new equilibrium. Then this is going to, okay. So this is then going to be 4x. And then obviously, like we had established before, this is going to be 8x. Now we can get the new equilibrium by saying what, ladies and gentlemen? Now we are then going to say 0.462 minus 8x, and then we're going to say 1 minus 4x. So that's the information that we had so far. Okay, right. Let's think about it. Let's see how we find so far. Okay, so now let's take this into our Kc expression. So for the Kc expression, we are going to say this is going to be concentration of the product, which is CS2, over the concentration of sulfur, which is then squared. So this is then going to be, what was it? Okay, our Kc was 9.4, by the way. So that's 1 minus 4x. So that's 1 minus 4x all over. Oh, now, but remember that 1 minus 4x is the number of moles, not the concentration. So we need to convert that into concentration, which is number of moles over volume. So that's 1 minus 4x over 4, which is the volume. Then this is going to be that part there, which is 0.462 minus 8x divided by 4. But remember the coefficient as an exponent, and then we square. And then that's that. That's the final answer. Because remember, they just said they wanted it written in terms of x. You didn't have to simplify or solve for any x value. Just have to leave it there, and you should be fine. Right, that then brings us to the end of this question. I will then leave it here and see you guys in the next video. Goodbye.